So that is the practice that you picked up. And I put that together pretty fast this morning. So if you come across an answer that you think is wrong, then let's check that, because that could very possibly happen. So what we're covering today are things that you'll see on the quiz on Friday. All right. So yesterday we talked a little bit about factors that affect the rate of dissociation, or the rate that something goes into solution. And today we're going to talk about how much goes into solution. So some of the factors that affect that are temperature. So we could first of all have an increase in temperature, and that would increase the solubility if you have a solid solute in a liquid solvent. So if we have salt and we're dissolving it in water, if we heated up the water, we would be able to dissolve more salt. Opposite of that, we would have decrease in the temperature, and that increases the solubility if you have a gas in a liquid. So like our carbonated drinks, that's why we like them cold, because then more of the CO2 goes into solution and they're kind of more fizzy. And then the other thing that we can adjust would be pressure. So the solubility of a gas increases as the pressure above the liquid solution increases. So that's just if we're going to have a gas as a solute. If I have a liquid or a solid, then the pressure is not going to change that. So for a gas, as I increase my pressure, I will increase my solubility, or how much will go into solution. So what happens when you leave your Coke? Like open it up and leave it laying around for a while. Goes flat, right? And that's because the pressure, whenever it was closed, there was a lot of pressure. It was holding the carbon dioxide in solution. And then we open that up and we decrease the pressure, so that it's easier for that carbon dioxide to, that carbonation to get out or to leave the solution. And this is dictated by Henry's law, which says at a given temperature, the solubility of a gas in a liquid is directly proportional. And that formula looks a little bit like some of our gas laws. We're not going to work any problems with it. So you just really need to know that relationship, and then it only really deals with gas solutes. All right. So now we're going to talk about solubility curves. And we're kind of interested in some different points along those. So solubility is the maximum amount of a substance that will dissolve in a solvent at a given temperature. And when you're doing units for solubilities, it's going to be grams of solute per either milliliters or grams of solvent. So if you just look at your solubility curve that you picked up from practice, on that first graph, it says that we're looking at grams of solute per 100 grams of water. So if we made some adjustment and we maybe change that to just 50 grams of water, then we would have to make that mathematical adjustment too. So that's why you need to be sure to notice what you have on your y-axis. Water has a density of 1 gram per 1 ml. So that means if I have 1 gram of water, it's going to be equal to 1 milliliter of water. That's not true for all substances, but it is for water. So on that one, it says that you have 100 grams of water. That's the same thing as saying that you have 100 mils of water. All right, so we are looking at an unsaturated solution. So that's a solution that can dissolve more solute. At that point, it does not have enough. And those types of solutions are shown on a solubility graph below the line. And then if it is kind of like a perfect solution, we have a saturated solution. And that means that you have just enough solution to handle all of the solvent. And that would show up on the line in a solubility curve. And the last one is if you have a super saturated solution, and that means you have too much solute. There's not enough solvent to handle it, and this is going to be above the line. Supersaturated, if you add more solute then crystals or precipitate will form. So with supersaturated, like I said, the solvent is already all taken up. So now if I try to add some more solute, it can't go into solution. So it precipitates out or it forms a crystal. And all these different things where I talk about below the line, on the line, or above the line, that has to do with the solubility curves. All righty, let's find the next one. There we go. All right, so if we look just at the solubility curve, you'll see at the bottom that on the x-axis it's temperature and it's increasing. And then on the y-axis that has how many grams, it's showing me how many grams of solute will dissolve in 100 grams of water. And all those different lines, each one is a different solute. So for instance, this line represents the solubility of Ki, of potassium iodide. So this is the line. Any points on this line are representing a saturated solution. So in other words, if I'm at 20 degrees Celsius, and that's my temperature, I'm going to go up until it hits that line about right there and come over and estimate, and we'll say maybe about 145 grams. That's how much solute can dissolve in that solution at 20 degrees. So we'll say, I don't know, we're going to say about 145 grams would be the saturation point at that temperature. So if I had something below that, so let's say I only had 120 grams, that's below the line. So that would be an unsaturated solution. And then if I went the other way, and let's say that we were right up here at 150 grams, that's above the line. So that would be a supersaturated solution. So that's what we're talking about when we talk about above or below or on the line. So the x-axis is your temperature. And it is increasing. And on your y-axis, you have your solubility, which is going to be your grams of solute per grams or milliliters of solvent. And you know which one it is by looking on your x-axis. So then this kind of some of these we've already said, if we're below the line on a solubility curve, then that represents an unsaturated, I'm just going to kind of shorthand it a little bit, an unsaturated solution. If we're above the line, then that is considered a supersaturated. And then over here, just repeats that again, above the line and all the solute is dissolved. And once again, we say that is a supersaturated solution. All right, so most substances, the solubility increases as the temperature increases. That's all the positive lines that you have up there. But there are two exceptions on the solubility curve. What are the two exceptions? What two have actually a decrease in solubility as your temperature is increasing? So they're going to have negative slopes. NH3, right? Which is a gas at room temperature. And which other one? That's succinium sulfate. Those both have a negative slope. So you see that a lot of times with gas. Ammonia, like I said, is a gas at room temperature. Succinium sulfate is probably just an exception. All right, so let's start kind of looking at some of the different problems that you might see. All right, so it says what mass of solute will be dissolved in 100 mils of water? That's exactly what we have going on here. 100 mils, 100 grams is the same thing at the following temperature. So I'm looking at potassium nitrate at 70 degrees. So I start here at my temperature at my 70 degrees, and then I'm going to go up until it intersects the potassium nitrate line, which is right here. And then I'm going to come across over here and I'm going to read how much. So that would be 130 grams can dissolve at that temperature in that amount of solvent. Notice this is just asking for what mass of solute. It isn't asking for what is the solubility of. The solubility of, you'd have to put it in grams per milliliter of solvent or per grams of solvent. Here it's just asking for a mass. All right, why don't y'all try those other two? Remember, you start at the temperature and then you go until it intersects the line of the compound you're interested in. All right, what did we get for B for our sodium chloride? 40 grams? Yes, no? And there's some estimation that goes on here. I mean, you might, if you saw it as 39 grams, I mean, or maybe 41, those are fine. And as far as sig figs go, we really not gonna worry about that much either, because kind of with the graphs that are made, they really don't pay attention to that. All right, and then what did we get for C? 70 grams, all right, that's what I got to. All right, so which of the above three substances is the most soluble at 15 degrees? Anybody got one for that? I think it's NaCl. Here's my 15 degrees. And then these lines kind of get all blurred here in the middle. But I think this is my potassium nitrate. So it's down here. My sodium chloride is kind of right here. And then what am I leaving out? where's that sucker at? Oh, right here. So it comes about right here. So they're pretty close together, but the one that is a little bit higher up is the sodium chloride. So the most soluble one's going to be the highest one at that temperature. The least soluble one's going to be the lowest one at that temperature. Like I said, sometimes these get a little jumbled up. It's kind of nice if sometimes you go in and color code if you're going to be working with it a lot. Which reminds me, if you look at your practice on the second page, if you look at that graph, I think right in the middle it says KNO3 potassium nitrate, but there's no line by it. Yeah. Yes, okay. So if you have any questions about potassium nitrate, I tried to underline them, then you're going to just need to flip to the front and use that graph. I don't know what happened to that line. Whenever I copied it or printed it out, it disappeared. So just flip to your other one. All right, let's see what else we got going on. Now, are you looking for practice? Yeah, it should just be laid up there. All right. So this is kind of a repeat. We've kind of already said this a couple of times too. We're looking at on a solubility curve, the line indicates the concentration of a saturated solution if we're right on the line. Values on the graph that are below the line or the curve are going to represent my unsaturated solutions. All right, so now we're going to look at a few situations and we're going to say whether they're saturated or unsaturated, and then if it's unsaturated, how much more of the solute we need to add. So I'm going to flip over to the next page, and I should have adjusted those notes. So that would have. All right, I'm going to have to go up here. So we just look at the first one. On the first one, it says, what do I have? I have 70 grams. Just going to jot it down here. 70 grams of sodium nitrate at 30 degrees Celsius. All right, so I'm going to start at my temperature. And I'm going to go all the way up until it hits my sodium nitrate, which is right there. That gives me a saturated solution, so maybe 95-ish, 94-ish grams. But I don't have that much. I only have 70, so I'm down here. So is that saturated or unsaturated? That would be unsaturated. And then the next question is, how much more do you need to add of the solute to get it to saturated? So what are you going to have to do on that one? Just do a little subtraction, right? We said to be saturated, it needed 95 grams, but we only had 70. So we would need to add 25 more grams to get that to a full saturated solution. All right, why don't y'all try the other three in that little boxed area? What time did y'all get home? Not as bad as drama. Huh? All right, what did we get for number 2 for the second box? Saturated or unsaturated? Saturated, so we don't need to do anything else with that one. And number 3, saturated. And finally, the last one, unsaturated. And how much more do we need to add? About 60 grams, right? 130 grams would be saturated at that temperature, but we only had 70, so we subtract and get that difference. All right, any questions on that one? Let's move on a little bit. Next one, it says at 90 degrees Celsius, you dissolve 10 grams of potassium chloride in 100 grams of water. And then we want to know if it's saturated or unsaturated again. So we're at, our temperature is 90, and I'm looking at KCl, which is right there. So that gives me saturated, I don't know, maybe 52, 53, something like that. But we only had 10. So we're way down here. So that's definitely going to be what kind of solution? Unsaturated. And how do you know? Yep, that's it. That's simple. It's below the saturated line. All right, let's look at number 2, which I completely forgot how to do in one of my classes, but I've regrouped since then. All right, we have a mass of 100 grams of sodium nitrate at 80 degrees. So I'm going to look for my 80 degrees, and that's right here. It says we have 100 grams. 80 degrees, 100 grams. So is that saturated or unsaturated or supersaturated? This is sodium chloride. This is what I'm interested in. So once again, that is unsaturated. It says, as the solution is cooled, at what temperature should we first start to see a solid? So that means that we're going to start to cool it. So that means I'm going to start to move this way. And when it finally hits that line, that tells me where I'm going to actually finally cool it enough that I will start seeing some precipitate. So it crossed that line, you know, you'd estimate it probably about 35, 34 degrees. So that was a little tricky. But if this is how much solute I have and the temperature wasn't high enough to dissolve it, I need to start changing my temperature. So as I decrease it, I come across there and I see what that temperature becomes. Anybody have any questions on that one? That one's a little bit more tricky than some of the other ones. All right, and why don't y'all give number 3 and number 4 a try? Those are pretty easy. All right, under number 3 for the first one, the 20-degree one, what was that? Which is the most soluble? Ki, right? Remember, most soluble, I start at the temperature they give me, and then if I want the most soluble, I got to go until I hit the very last compound. And then the least would be opposite. So if I want the least at 40, same thing. I start at that temperature and it would be the first one I hit. So that's, again, that's succinium sulfate. And so number 4, which one is least soluble at 10 degrees Celsius? Potassium chlorate, KClO3, exactly. All right, and then the last one here is a little addition or subtraction. I can't remember. It says I'm looking at potassium nitrate. So that's this curve right here. And I said I have 80 grams dissolved in the water at 50 degrees Celsius. The solution is then heated up to 70 degrees. So when I move up to 70 degrees to get it saturated, I need about 130 grams. That's how much I need it to saturate it when I raise my temperature. I need 130 grams. But I already added in 80. So I just would do that little subtraction. And that would tell me the difference, which would be about 50 grams. That means I need to add about 50 more grams to make it saturated if I increase my temperature that high. So try to do some practice at home so you can come with a few questions tomorrow, and then we will move on to molarity, which I don't think it's too bad. So you'll see some of this on the quiz on Friday. All righty. recording.